What's up, guys? In today's video, we shall be talking about the basics of circles. Also, will include a few will include few theorems. Now, first thing as to how to approach circles is stop trying to stick on to your teacher's advice in school. Okay, they'll be like half of them are trying to finish the chapter as early as possible, which is completely fine. But most of them are trying to ignore the chapter. What I'm trying to tell you here is don't skip the chapter. Now let's dive into the basics. Obviously, all your third standard basics. Circle, this will be called as center of the circle, and any line drawn from the center will be given the word will be called as the radius. Obviously, twice the radius, this specific concept will be called as the diameter. Now, along with this, you're supposed to learn few more things. Whatever I do right now, let's name it as point A and point B. Now, please try to follow me in this video. Instead of me trying to name the points as A and B, which is obviously called as a chord, I'll call A and B as points of origin. I'll repeat that. It'll be called as points of origin. Points of origin. Points of origin. Points of origin. So from now onwards, whenever I'm trying to use the phrase called as points of origin, I am trying to mean either about the chord or the diameter. And obviously everybody knows here that the diameter is the largest chord. Fine. Now, a few more things about the circle. I'll try to redraw one more. So let's say the center, I drew a chord right now. Obviously, the chord is trying to touch the circle in 2 points. Those 2 points are called as the points of origin. Now, why am I trying to use this phrase? A little later, you get to know. Now, if you see, that chord is trying to divide the circle into 2 faces. The below face, okay, 2 segments. The below one will be called as the minor segment. The top one will be called as the major segment. Okay. Now, there are other things also. Minor arc, major arc, all those things are required. But I think we are good to go with the theorem. Fine. So, let's start with the ones which are actually, okay, in today's video, I shall be covering 5. I'll try to divide the 5 into 2 different parts. 1, 2 and 3 will belong to, let's call it as category 1. Category 2 will be 4 and 5. I'm telling you, try to learn theorems this way. So theorem 1, 2, 3 will be category 1. Theorem 4 and 5 will be category 2. That's how it works. Now, category 1, the first theorem goes like this. It says angle subtended. I'm pretty sure you guys are able to see the screen. It says angle subtended at the center is twice the angle subtended at the circumference. Before me trying to explain the theorem, what are the most important words? Subtended, it's important. Okay. Now, again, let's try to zoom into the circle a little bit. So if you see here, I've intentionally drawn 2 specific points. Again, a chord might be missing here. Now I'll pause for a second. Your school teachers might have told drawing a line is always essential. Ignore them. Not at all required. You need not draw. They'll be like, try to draw an imaginary line. See, if you're too weak at math, only then draw. If you're too weak in trying to be creative, it's only then draw. Okay. But I'm pretty sure at this level, you'll be able to understand what 2 points mean. So that imaginary line is not at all required, is what I'm trying to tell you. Fine. So let's stick on to the theorem again. It says, I'm pretty sure you guys can see 2 points. Always tried, again, category 1 question. Always try to locate the angle using your hands. Fine. So place 2 fingers, obviously 1 each. Place 2 fingers at the points of origin. Fine. You place your left hand here, left finger here and right finger here. And what are they trying to tell us? They're trying to highlight 2 different words for us. One is they're trying to talk about the circumference and they're trying to talk about the center. Now, if you see here, I'll try to mark the center right now. Please focus there. So I'll mark that to be center O. Fine. So place both the fingers at the points of origin. In this case, the points of origin are A and B. Will it always be A and B? Need not be. Fine. Now, place 2 fingers at the points of origin and go towards O. So you'll be going in this path. Now, if you see, go back to points of origin and from the same 2 points, go towards the circumference this time. So the first time you went towards the center, this time we're trying to go towards the circumference. Now, what are they trying to tell us? They're just trying to tell us if this value is x, the circumference value is x, then the angle subtended at the center will be 2x. This will be 2x. That's it. If you're not able to understand with respect to letters or variables, I'll try to give another example. Focus on the example here. Again, first of all, step number 1 is to identify the points of origin. Okay. But before that, step number 0 also is required here. Supposed to identify the center. Center O is done. Points of origin here, I can see here, left hand side is A, right hand side is B. Again, place 2 fingers. one finger on left side A, on the other finger on at point B. Now go towards the center. What's the center? It's O. Now it is given to us that AOB equals 100. Now again, place both the fingers at AB again, called as points of origin. Now go towards the circumference. Now in this question, the circumference has not been specified with any of the letters. Ignore it, completely fine. Okay, but if you want me to do it, I can do it. I'll name it as D. So we're trying to, from A and B, we are trying to go towards point D here. Now, since the points of origin is the same, I'll repeat that. Since the points of origin is the same, AB and AB, so obviously angle ADB, you guys tell me, don't you think will be the half of it? So it will be 50 degrees. Okay, now this specific theorem has a lots of do's and don'ts. It's very important. So what happens here is, I'm pretty sure, I mean, everybody understood the theorem. It's pretty simple, all these things. I can give you one more example. In fact, I'll take the same example. Look at this. This time, again, step number 0 is what? Is we are trying to find the center. Done. Now, step number 1 is trying to locate the points of origin. A, B. Now, check. AOB and ADB both have the same points, called as points of origin. Place both the fingers where? At A as well as B. Move towards O. Now, also move towards D. Now, since the value of ADB is given to us, the center will be double of it. Careful, will be double of it. So, this will be equal to 100. Now, there's a reason as to why I've taken two examples with the same numbers. I'll tell you why. I'm not going to be dumb here. Okay. Now, focus. Now, what are the do's and don'ts? The do's I've told you right now. You place both the fingers at the point of origin and you keep moving. Now, the don'ts. See, I'll tell you one small rule here, okay? Angles should always be facing, should not be facing each other. Should not face. Okay? Look, if you look at this, angle 100 here and angle 50 are not facing each other. Now, obviously, if you're trying to ask me what's the meaning of face, let me try to extend this diagram here. Now, there's a small confusion. I'll mark this point to be point E. Don't you think angle AEB also has the same points of origin? Now, what do? We place both the fingers at A and B. We come towards E. Now, we expect the answer to be 50. Why? The theorem tells us that. That's the point. That's the catch. Fine. So, understand here, if I try to draw this, don't you think the angle which I drew right now, I'm talking about AEB and angle 100, both of them are facing each other. So, since they are facing each other, this specific theorem will not be applied there. Remember that. This specific theorem will not be applied. So, when to not apply? When to apply, it should not be facing. When not to apply, if it is facing, you should not apply. So, this angle is not equal to 50 degrees. Okay, it's not equal to 50 degrees. Now, what is the, by chance in your exams, they try to draw like this. And if they ask you what's the answer for AEB, does it mean we do not have an answer? We have an answer. It is just that it is not equal to 50. Now, how do you find an answer? Very simple. So think, we know the angle AOB. What is it? 100. Somewhere in our lower classes, we learned this. No, this inner angle, let's say it is 100 degrees. The outer angle can also be found. It is called as reflex 100. We learned something called as reflex angle. The reflex angle concept I'll be using here. So what is the meaning of reflex angle? It is nothing but 360 degrees has to be the total. Now, if the one part is 100, the other part will be 360 minus 100, which is nothing but 260 degrees. Okay, so right now I'll find reflex 100. Reflex 100 is nothing but 260. Now apply the same concept. So the center angle at the center was equal to 260 degrees. Angle at the circumference will be half of it, which means this will be equal to 130 degrees. That's it. So please rewind the video and watch it again. But why am I trying to stress so much on the word subtended, the word center, the word circumference? Because once you write your answer in your scripts, in the bracket, when you're trying to state the reason, you're supposed to use the same language here. You can't use the word angle cut at center, angle cut at circumference. Wrong, incorrect. Okay, it should always be subtended at the center, at the circumference, twice, half. All these things have to be there. So this is theorem number 1. Now, again, since this belongs to category 1, the reason I told category 1 is because theorem 1, 2 and 3 are always dependent on theorem 1. Okay, so I'll tell you what I mean. Let's look at theorem number 2 of category 1 itself. Now it says angles in the same segment of a circle are equal. Now what do they mean by the word segment? Don't you think when I'm trying to explain the basics, I use the word major segment, minor segment? See, let's not dive deep into it. Okay, not at all required because There's an easy way to learn it. That's why. So I'll tell you what I mean. Again, here I'll mark 2 points. At this point of time, you should know what these points are called as. What are they? Obviously, points of origin. I'll name it to be A and B. Now, randomly, I'll start drawing. Focus here. I'll take the same values maybe. So this angle is touching the circumference. Fine. Now, I'll also draw one more angle touching the center. So if this angle is 100, what do you think the answer will be at the circumference? Half of it. So it will be 50. Now, my question is, from A, I'll draw one line to the circumference. From B, I'll draw one more line. Getting it? Now, don't you think, again, place fingers where? At the points of origin and go towards point E here. Now, D done, I'm going towards point E. Don't you think the point of origin is the same? If the point of origin is the same, I'll have to apply theorem 1 there also, correct? So, this also will be equal to 50 degrees. Now, let's try one more. I'll place both the fingers again at the point of origin. Now, I'll try to draw one more. I'll name it as F this time. So, since the point of origin is the same, we know one concept. What is it? If the center is 100, the circumference will be half of it. So this will be equal to 50 again. Now, don't you think instead of me trying to apply theorem 1 again and again and again, that is, they're trying to compress it and tell me angles in the same segment are equal. Don't you think AEB, ADB and AFP, all of them are in the same segment? So since everyone is the same segment, you can directly tell the answer as 50, 50 and 50 without even trying to do theorem number 1. That's it. So simplified version of theorem 1 is theorem 2, or let's say step number 2 of it. That's how it works. That's it. Let's go to theorem number 3. Now, theorem number 3 also depends on theorem number 1. The only catch here is they've used a fancy word here. They've used angle in a semicircle is always right angle. I'm pretty sure at this point of time, you guys know the value of right angle is 90 degrees. I'll prove it to you as to how it is 90. But before that, the most important word here is a semicircle. Now again, step number 0 is what? Step number 0 is always trying to find the center. It's here, center O. Now, more than that, I wanted step number 1 is always trying to identify the points of origin. I think that's visible here. I'll name it as A and B. AB is a straight line. Common sense, no? Which means angle AOB here is equal to 180 degree. Everybody knows. I think I made a small mistake. I'll draw the angle inside like this. Whatever, anything is fine, man. Actually, it won't make any difference. Okay. Yeah, anything. This only is fine. Cut this part. We'll do the same concept here. What is it? Place both the fingers at the point of origin. In this case, it is AB. Move towards the circumference. Again, wherever the word circumference is used, it becomes half. No, getting it? So right now, you're placing your fingers at A and B. You're going towards the circumference, which means the answer has to become half. What is half of 180? 90. Making sense? Half of 180 is nothing but 90. Therefore, they use the word semicircle. Similarly, let me apply theorem 2 to this concept right now. Theorem 2 will look like this. From here and from here, I extend. Correct? Now, 90 degree, I can write directly. Why? I'm applying theorem 2. What does theorem 2 say? Look at that. Read that. Angles in the same segment of a circle are equal. Same concept. So both of them are in the same segment. Therefore, even before applying theorem 1, directly, since I know the answer, you can write it as 90 degrees. But mentioning this is very important. Angles in a semicircle is always 90 degrees or a right angle. Now category 1 is done. Let's go to category 2. Now before going to category 2, it is important for us to understand a small concept here. Let's go back to our 8th or 7th standard. We learned something, a four-sided figure is called as a, no, please don't tell square or rectangle. Generally, it is called as a quadrilateral. Okay. Now, I use that concept, and if I place that quadrilateral inside a circle in such a way that this does not look like a circle, but it's fine. Right? In such a way that all the four corners are meeting the circumference. I'll repeat that. All the four corners are meeting the circumference, then this specific figure will be called as a cyclic quadrilateral. Fine. Now, what not to get confused? People think, okay, draw a circle. They'll be like, isn't this a quadrilateral? No. Look at this. It is not touching the circumference of the circle. So this cannot be called as a cyclic quadrilateral. Wherever you're trying to use the CQ, cyclic quadrilateral, all the four corners should be a part of the circumference of a circle. Fine. Now, this is the basic part of it. If you understood the basic, we'll go to category 2. Category 2, the first one. So apparently this is theorem number 4, but under category 2, this is the theorem number 1. That's how it works. Now it says opposite angles of a cyclic quadrilateral are supplementary. Fine. Let's try to prove it here. So for that, I'll try to draw a circle, cyclic quadrilateral. I'm trying to draw a four-sided closed figure in such a way that all the four corners are trying to meet. Fine. I'll try to assume a random angle also here, but before that, let me name it. I'll name this to be A, B, C as well as D. Obviously this will be 75 degrees. Again, think. Let me place my finger at the point of origin, B and D. Assume. Okay. I'm placing and I'm going towards A. I got the answer to be 75 degrees. But if let's assume there was a center. I'll draw a dotted line here. If this is the center, obviously this will be 150 degree. How do I know this? Theorem number 1. I got the answer as 150. Fine. Now think for a second. I told you, don't you think I'll be able to apply theorem number 1 again? So what do we feel is, we feel that this also should be 75 degrees, but that's not the case. Why? I told you one trick, no, the do's and don'ts. I told you that it should not face each other, but right now it is facing each other. Getting it? So by chance, if it is facing each other, I also gave you a trick to solve it. What? Take the reflex angle of it. Reflex meaning I'll be able to find this angle. What is reflex of 150? First of all, what does reflex mean? 360 degrees. Minus 150, I got the answer as 210. So the outer angle is nothing but 210. Now if the outer angle is 210, apply theorem number 1 again. So place your fingers at the points of origin. In this case it is B and D. Go towards the center. Center was 210. Why am I not taking 150? Because it should not face each other. That I'm applying here. Okay. Go towards the center, 210. So the half will be BCD. What is half of 210? 105 degrees. Getting it? Now, I'll try to take off all the useless parts of it. Now, only focus on the 75 and the 105. Don't you think both of them are opposite angles? Opposite angles. That's what the theorem says. It says that opposite angles of a cyclic quadrilateral. That's the case. Not quadrilateral, but a cyclic quadrilateral are supplementary. The meaning of supplementary, everybody knows, is equal to 180 degree. So you add angle C plus angle A, you will be getting 180 degree. Now, again, category 2 has one more theorem. Let's try to talk about that theorem right now. Imagine I extend this line called as BC. Imagine I extend this line and call it as BCF. It's a straight line. So don't you think after extending it, this angle can be found? Correct? How do I do it? Angles on a straight line are always equal to 180 degrees, or also called as linear pair. Correct? Now, 180 degree minus 180 degree minus 105 degree, the answer here will be 75 degrees. Correct? No. Now, don't you think this is exactly my next theorem? Don't you think the double line the double angle which I marked right now can also be called as exterior angle? Exterior angle. Fine. So we had learned a similar property like this in triangles. I'll modify it a little. Fine. Now it says that theorem 5 says that exterior angle of a cyclic quadrilateral is equal to, careful, exterior angle of a cyclic quadrilateral is equal to interior opposite angle. That's it. Exterior angle is equal to interior opposite angle. Theorem 5 done. Okay. So to recap, theorem 1, angle subtended at the center is twice the angle subtended at the circumference. At the circumference, if it is x, at the center it will be double, called as 2x. Now theorem 2 also depends on theorem 1. What does it say? Almost the same. It says that angles in the same segment of a circle are equal. So AEB, ADB and AFB will all be same. That's what theorem number 2 says. Theorem number 3 is again dependent on 1 and 2. It says what? Semicircle. Semicircle meaning diameter is the chord here. Obviously, is the largest chord. Fine. So apply the same concept here. Place both the fingers at the points of origin. Go towards the circumference. It becomes half. Correct. So here the angle was 180 degrees. Semicircle meaning 180. It becomes half. 90 degree. Done. Category 1 done. Category 2. You guys know the meaning of cyclic quadrilateral. It means that the quadrilateral has to be inscribed in a circle, has to touch the circle, all the 4 corners that you draw. Now, opposite angles of a cyclic quadrilateral are supplementary. This also depends on category 1, but I'm not talking more about it. So, if this is 75, this is 105. Let's go one more round, okay? Let's say this is 100. This will be equal to 80 degrees. How? Opposite. Getting it? Now, let's continue with the last theorem. It says, once you extend the line, there will be an exterior angle formed. that exterior angle of a cyclic quadrilateral is equal to interior opposite angle. So these are your theorems, and this is part 1 of it. Now, why am I trying to call it as part 1? Because the remaining theorems will be in the next chapter called as tangents. Fine. So in the further videos, we shall be solving questions based on these theorems. I'll see you in the next video.